receipt it will show here.
Good evening to all of you. I welcome you in this webinar organized by University of Petroleum and Energy Studies. Myself Geetanjali Raghav, Assistant Professor in the Department of Mechanical Engineering. In this session, I'll be briefing you about the most exciting and evergreen engineering domain that is known as mechanical engineering. Before proceeding towards the details of mechanical engineering, its career prospectus and other things, let's have a little look about our university and our department. University of Petroleum and Energy Studies is the Asia's first energy and core sector university having a multidisciplinary area specialization too. Our university has three colleges: College of Engineering Studies, College of Management Studies, and College of Legal Studies, spread over two campuses known as Knowledge Acres and Energy Acres. We have a well-established research and development infrastructure along with a skilled specialized laboratories where you can convert your dreams into reality. College of Engineering Studies, at this college you can look forward to have your bachelor's degree as well as master's degree in most of the exciting engineering domains, and of course mechanical engineering is one of them offered by our department, Mechanical Engineering Department. Now let's have a glance at our department. In this slide, as the arrow is showing, we have our department located in this building. Our department offers undergraduate courses in mechanical, mechatronics and AD, MTech programs in pipeline, rotating, thermal, design, and of course, higher degrees, doctoral. The key competency skills of our department is our 50 plus highly qualified and experienced faculties having expertise in more prospectus. We have an intensive research prospectus in the area of biodiesel, solar, material science and nanotechnology, and we have the specialized research labs for that. Now let's have an outline what we are going to discuss in this session. We'll be discussing about actually what mechanical engineering is, what is its course curriculum which you'll be studying in this 4-year tenure while offering this as your program, what is the laboratory infrastructure we have to convert your dreams or to convert your ideas into reality, what are the students chapters we have, what are our prominent and major recruiters, and of course, what are the career opportunities you have after being graduated from our institutions. So let's start with, before opting mechanical engineering as your program, you should be aware about actually what engineering is. So as the name indicates, mechanical engineering, where motion is involved or certain mechanism is involved. Mechanism means which converts input to output. So wherever motion or mechanism or input output functions are involved, there we have the mechanical engineering. It deals with anything that has motion and performs a function. The scope ranges from need, ability, vision to design to manufacture tiny to larger components. Your mechanical engineering components or mechanical engineering area starts from the tiny gear arrangement lies within your wristwatch to the larger thermal power stations. You can find your mechanical engineering component anywhere involved where there is a motion or mechanism involved. The American Society of Mechanical Engineers, ASME, currently lists 36 technical divisions from energy system to solar energy and textile engineering. And our department not only converts this 36 technical divisions but also incorporates all its flavor into our 4 domains. in the form of program electives that we have thermal, design, production and industrial, and materials. So it has a very broader and wider scope. You can find your job, you can find your career anywhere where there is an industry, where there is a system which involves a mechanism. Let's take some examples where our mechanical engineering is indulged. If we talk about an aviation industry, you can find out your thermal engineering, which is a specialization or which is a part or a component of mechanical engineering in the form of engines. While designing these IC engines or designing the body of an aerospace industry, you need to have material knowledge, you need to have a design knowledge, and when these all three domains are converted and converted into reality, they becomes a manufacturing part. So all these four main domains of mechanical engineering is involved in an air industry. Simultaneously, if you look about a power plant industry or a power plant sector, there also thermal production and materials are involved. Thermal, they convert chemical energy into electrical energy, production is involved here, and as well as different materials are also involved. So to work in any industry, you need to have to gather the basic and core knowledge of mechanical engineering in all these four prominent areas. Now, after opting this branch or after opting this program, what you are going to study through the 4 years tenure? In semester 1 and 2, that is your first year. In this year, you'll be gaining about the basic science knowledge that is required in studying your fundamental engineering or in studying your core engineering and in studying your advanced engineering. Physics, maths, environmental studies, chemistry is required. Without having basic science knowledge, you cannot go through your core, fundamental or advanced mechanical engineering subjects. So it is must in the first year. Then in the second year, as we are seeing in the slide, we are having some fundamental mechanical engineering subjects like fluid mechanics, in which we study the behavior of fluid, like mechanics of materials, in which we study the behavior of materials, the properties of materials, manufacturing technology, in which we study the technologies which are being used, the basic technologies or the basic knowledge of the technologies which are being used in manufacturing something. Then we have machine and assembly drawing, in which we learn how to design, how to draw, or how to gain a particular structure of a machine or a system. We have engineering thermodynamics, in which we gain the basic concepts related to the thermodynamics part, that is heat, motion involved in that. Then we have applied thermal engineering, and to gain something social knowledge to you, we have certain open electives too. Moving towards the third year, now your fundamental engineering is being transferred to your core engineering. Whatever you have learned in your second year, the basic concepts or the fundamental concepts, you are going to apply those concepts, your theoretical knowledge into the practical one. That's why we have introduced the practical subjects or the core subjects in this year. We have heat and mass transfer, in which engineering thermodynamics theory will be applied. We have refrigeration and air conditioning, in which whatever you have studied in thermodynamics, you can apply that. We have fluid machinery, which gains its knowledge from fluid mechanics that you have studied in second year. We have industrial engineering. In industrial engineering, you will be learning about how to increase the production, how to control the quality of a particular production system of a particular industry. So it is very important to study this. Then we have IC engines, manufacturing technology, part 2, that involves the theoretical knowledge gained from manufacturing technology part 1, or in part 1 you might have learned about the basic technologies. Here you'll be learning about some different or new technologies emerging. Then in final year, you have a subject known as CAD CAM, computer aided designing and computer aided manufacturing. That means your design part and your manufacturing part has been automated by the use of computers nowadays. You are going to study how you can automate this, What are the techniques, what are the methods, what are the operations, or what are the manufacturing technologies that are automated now. Then we have operation research. Operation research deals with to get maximum output out of limited one. As we are seeing here, we are having certain program electives too. Thus, we have discussed in the previous slide too that in order to incorporate the 36 technical divisions, we have introduced these program electives. We'll talk about this in our next slide. Program electives that you'll find in your third year and mainly in final year. American Society of Mechanical Engineers in divisions of mechanical engineering, and our department has converted those 36 technical divisions and the flavors of those 36 technical divisions into major 4 domains, that is thermal, design, materials, production and industrial. These 4 domains not only converts or covers these 36 technical divisions of ASME, but it also meets the industrial requirement that we are facing today or for which we are generating our product. So these 4 domains are designed in the form of program electives to meet the industry requirements as well as the ASME technical divisions conversion too. What program electives we have? We'll see now. As we can see, the red colored portion, program elective 1, that is common, in which we are going to work study and ergonomics. Ergonomics is something about that how a chair should be designed, how a sitting system should be designed, how a working environment should be designed, so that the stress should be minimum. And then you have automobile engineering, the engineering related to automotive sectors. Then we have program elective 2, 3, 4 and 5 in 7th and 8th semester. Program elective 2 has all the subjects related to your thermal domain, related to your production industrial engineering domain, related to your design domain, related to your materials domain. And similar thing is with program elective 3, 4, 5. In thermal domain, we have air conditioning systems design. We have convective heat transfer systems, solar thermal systems, power plant engineering, steam and gas turbine, advanced IC engines. That means we are moving towards the advanced section of thermal systems. How to design them, how to correct them, how to study the advanced technologies related to them. In production and industrial engineering, we have industrial automation and robotics, engineering economics and financial management, production and operation management, product design development, design for manufacturing and assembly. In this, you are heading towards, from the basic concepts, you are heading towards the automation part, the advanced part of production, how to increase the production, how to improve the production, what are the quality measures which you can involve in a particular industry to increase the production. We have outlined the subjects like that. Then in considering the design domain, we have mechanical behavior, advanced mechanics of material, modeling and simulation of particular system, finite element analysis, advanced theory of machines, design for manufacturing and assembly. As we are seeing from the subjects, it is clear to us that in the design field, we are heading towards from the basic concepts towards the advanced technologies or the advanced methods for, like we have modeling and simulation, in which we can model or design a certain system or certain machine in softwares. We have finite element analysis, in which we can analyze a particular system on minute level. Then we have advanced theory of machines. In theory of machines, we deals about the governors, we deals about the gear systems, we deals about different mechanisms. While heading towards the advanced systems, we have advanced theory of machines. Moving towards the materials part, we have mechanical behavior of materials, how materials behave when they are converted to composite systems, when their internal properties are changed at nano level. That is what nanotechnology means. Then we have nanotechnology, we have polymer, ceramics and composites, nanomaterial processing and their application, which is the most booming section in material domain nowadays. Then we have corrosion science and technology, thermodynamics and phase transformation. So this was our course structure which we offer our mechanical engineering students in our 4-year duration. Now moving from the theory part, moving from the subject part, now how you are going to apply your theoretical knowledge to the practical one. Until and unless you have a hand-on experience on whatever you have learnt in the theory, you cannot, your learning, your education, your uh, degree is not complete. So in order to convert your theory portion to the practical one, or to expose you practical environment, how industries actually work, whatever machines they have, how research is processed, we have a well established and a skilled lab infrastructure. Starting from the basic one, as we have machine shop, in which we just give our students a basic knowledge about the basic processes involved in a particular industry. Like we have, starting from the first figure, we have lathe machine, then we have drilling machine, then we have shapers and slaughters. The basic machines, basic introduction of how a process has gone on in a particular industry, how turning happens, how drilling happens, how a metal piece is converted into certain designs or certain format or certain pattern, how it happens. Then we have foundry section, in which you are seeing in the first figure we have a mold of a dot mold. Then you can create your dot here, how this is manufactured or how this is created, you can have it in foundry section. Then in the second figure we have certain tools involved in our foundry section, and how the actual system occurs after foundry, we can see it in the third figure. This is also one of our basic section, that is your blacksmithy section. We might have gone through in our day-to-day life about this section. In a practical environment, how these things actually happens. Then we have our refrigeration and air conditioning lab, one of the most established lab. We have in this lab, we have an air conditioning setup by Hilton, and refrigeration test rig, air conditioning test rig, in which we study the behavior of air which flows through a refrigeration test setup or an air conditioning test setup. How refrigeration happens, how temperature variation is happening, how your air is cooling in an AC setup. We'll related to an AC system or a refrigeration system. Moving towards our materials and metrology lab, we have our profile projector. In the rightmost figure, we have our profile projector, an advanced machine. Then we have a 3D printer, we have certain materials advanced to study the material behavior. Then as mechanical engineering is also involved, the automotive chassis or automotive sector. So we have an advanced and well-established automotive chassis lab too, in which all parts of an automotive system can be tested, can be maintained, can be discussed through this lab. Then moving ahead towards the engine testing. Engine testing means when we are interested to discuss the performance characteristics, to discuss the exhaust characteristics of a particular engine, how it performs, whether it is performing good or bad, or SI engine, diesel engine, petrol engine, how they are performing, what are its exhaust characteristics. Or we have all the setups to find out these characteristics, to improve these characteristics, and to test these characteristics. So that happens in the engine testing lab, as we can see from this slide. We are having engines in which we can test our fuel. Material testing. In the leftmost figure, we have a Brinell hardness setup in which we test the hardness of a particular material. Then we have a Rockwell hardness test setup as in the figure, in which we can test the hardness of a particular material. Then we have one advanced machinery with us in which you can test or you can check the different mechanical properties of a particular material. This is one of the advanced machinery we have with us. Then, of course, we have a fluid mechanics and machinery lab in which we are going to gain the basic fluid concepts and whatever fluid machineries we have, turbo machineries we have in our system. We have Kaplan turbine, we have Francis turbine, we have reciprocating pump setup, we have centrifugal pump setup. In fact, we have a MIG test setup too, in which we can go through the components involved in a particular MIG engine. We have that test section too. You can see the downmost figure. Moving towards theory of machines, in which we have earlier discussed that we are going to study the governors, we are going to study the gyroscopes, we are going to study the energy storage systems, we are going to study different systems involved which are there in your theory syllabus. All setups we have it in our lab. We have gyroscopes, we have governors, flywheels, energy systems, storage systems, and a lot of them. One of the most advanced lab, computer aided manufacturing lab, in which you have an automated CNC, computer numerically controlled lathe, in which all which you have studied in a gone through in our earlier slide, lathe that has been automated in this lab, and that setup we have in our laboratory, and that is CNC. So this is one of the most advanced laboratory we have. Curriculum, we have engineering graphics as a subject in which we learn how to design a particular system, a particular machine. Now, as we have already learned that all the design systems have been automated, so we have a CAD laboratory too, computer aided design laboratory, in which we have the most prominent softwares with us to design a particular machine, a particular system, and to analyze its behavior too. Like we have Gambit, we have CATIA, we have SolidWorks, ANSYS, Fluent, and many more. Like I talked in our department slide that we have an intensive research prospectus too. Regarding that, this is our IC engine research lab in which various fuels have been blended and tested under this engine research lab, in which we study that how a particular fuel after blending will behave, what will be its performance characteristics, what will be its exhaust characteristics, how we are going to improve the efficiency of a particular engine by blending the fuels. Then of course we have biodiesel research lab in which we just blend different biodiesel systems, different fuels obtained from natural plants and converted into biodiesel and use, and of course we tested it in our IC engine lab too. We have tested Jetrofa, we have tested different biodiesel fuels in our IC engine lab. So that's what our research speaks. Bosch, our mechatronics lab, a center of excellence in which we have small assembly section of a huge car industry, car manufacturing industry. You can see all the operations there, whatever happening in an actual car industry or an automotive industry, you can see all the operations there. We have certain automotive robotic systems also there in our Bosch. Now let's talk about the student activities or the student exposure, how they can enhance their technical skills, how they are exposed to the industrial environment. Regarding that, we have our student chapters. Different Sparkfest has been conducted. As you can see in the pictures, various quiz, where technical competitions, where robo wars, where guest lectures have been performed under this chapter. Then we have IIM and SSPC, where Padarthan was conducted in Delhi, and our students have participated there. We have international guest faculties and a lot more activities, a huge number of activities going throughout the year under these chapters. That means under these chapters you get an enormous opportunity to explore yourself as a technical person, to enhance your technical capabilities, and of course you'll get an industrial exposure too, to build up the industrial and academia relationships. Finally, to why we have started this branch, why we are going through this program, what is our ultimate objective according to the students is the recruitment process. We have our prominent recruiters which have visited our campus this year, and the placement process is still going on. We'll be completing it by the end of the May. The most prominent companies that have visited our campus is Aviva, of course, a German company established in Cambridge, UK, a software company that provides a technical assistance or a technical solution to the marine industries, to the power plants, and a lot more. We have Maruti, all of us know about this. We have Hyundai in our campus, we have Mahindra in our campus. Of course, we have ITC hotels in our campus. ITC hotels are basically Indian Tobacco Company. It is a branch of ITC, Indian Tobacco Company, and it has its green campus. Green campus means a campus based on renewable energies. So they hired our students on for their green campus. Then we have Tata Projects, High Tech Robotics, Mantrucks India, Tata Technologies, Rane Steering Systems, which deals with steering as well as sitting with safety systems. And this is the little about our companies, and many more are there in the list. The list is a little, but the final list is endless. Now, after completing your 4-year degree in mechanical engineering, what are the career opportunities apart from the placement you can get after becoming an mechanical engineer? As this is the age of machines, and where there are machines, there is opportunity for mechanical engineers. Wherever you find a machine working or a mechanism going on, let's take an example of a biscuit manufacturing industry. You can be hired there as a production engineer, you can be hired there as a maintenance engineer, you can be hired there as a design engineer, design of the machinery which involves in the production of biscuits. So it exists everywhere. There is production, where is machinery, where is mechanism, where is design involved. Let's see some of the areas in which you find your career opportunities. Aerospace industry. In aerospace industry, you can go to research field, you can go to design, manufacturing field, operations, and of course, aircraft maintenance too. Of course, you can go in automotive industries in which design, manufacturing, distribution, marketing, of course, and manufacturing part comes here in automotive industry. You can also find your scope in chemical industries, which covers all the oil companies, chemical manufacturers, and businesses that supports them. You can be involved in building a new plant or developing a new process technologies. Moving towards the construction industries, as we have seen, Tata Projects have visited us, and it is involved in the process of placement of our mechanical students. So Tata Projects is basically a construction based company which is dealing with industrial construction, urban construction, and domestic construction too. So you can find your career in infrastructure, buildings, and services. Definitely, like if you have studied the AC system, refrigeration and air conditioning, you can be involved in heating and ventilation system of a particular building. Defense industry, of course, this is the most prominent field where you can find your career as a mechanical engineer. You can find your career in providing equipment, support, services for the armed forces, securities too. We have different defense organization here, like we have DRDO, we have DEAL, we have ordnance factories in which these defense equipments are being manufactured, and mechanical engineers are definitely required there. Then you can find your career in electronics industry too, where you can design, manufacture components, complete equipment for the sectors from automotive to medicine and military. Fast moving consumer goods industry, like I have already discussed about a biscuit manufacturing industry. You can find your career there. You can find your career in household cleaning items where they are being manufactured. You can find your career in personal hygiene goods and, of course, convenience foods. Then moving ahead towards the marine industry, you can find your career in operations of different components of a marine system, or the development of the different components of marine system. Maintenance, electrical power systems and control systems. And of course, if you want to be an academician or a researcher, this is the perfect field for you. This is a small uh, surgery assisted automotive systems, in prosthetic limbs, a lot of them. In robotics, you can work on automation of a certain process, or automation of a certain industry, that like we have in our Hyundai plant, that established in Chennai. We have all the processes like welding process, like painting process, that has been automated now. No human working is required there. So that is an example, or a perfect example of robotics. That means you can build up your career in nanotechnologies, in which materials properties changes at nano level. You can build up there. You can work on thermal fluid systems, in which heat is being stored or energy is being stored in the certain thermal fluids, with those fluids which changes their behavior while heat is being stored within them. So these are the prominent or the most exciting areas which you can go through for your higher education. After completing your graduation, then of course you can find your career in design engineering, heating specialist engineer, mechanical, mold design. If you're working in a nuclear power plant or trying for a nuclear power plant job, you can be hired as a nuclear engineer. In any industry, you can find a job as a planning engineer, power plant engineer, robotics engineer. If you're planning to go to thermal power plants, you can be hired as a thermal power engineer, tool engineer, or if you're working on different blends of biodiesel or different blends of engines, then you can be a tribologist and many more. If you want to pursue your higher education, then what are the fields, specialized fields in which you can pursue your higher education? You can opt for mechanics. Of course, mechatronics and robotics is one of the prominent field. You can opt for structural analysis too. You can go for thermodynamics and thermosciences, in which, like I talked about in my earlier slides about thermal fluid systems. You can go for design, drafting. You can work on friction stir welding, FSW. You can work on micro electromechanical systems like sensors. These are the systems which comes under the category of MEMS, micro electromechanical systems. Systems which involves the electrical part and the mechanical part and combine them at micro level. You can work on composites, you can opt for nanotechnology, you can go for mechatronics, which is a combination of electronics and mechanical. You can work on finite element analysis. This is also one of the most advanced or prominent field in mechanical engineering. You can opt for biomechanics if you want to make your career in medical sciences, including or the advancement of the technologies involved in medical sciences. You can opt for biomechanics too. Then, of course, you can go for computational fluid dynamics, in which you just compute the dynamics of a particular fluid flowing using certain softwares. So, if you are interested in machinery, functions, robotics, material science, micro devices, weapons, design, aircraft, renewable energy systems, like solar energy, wind energy, ocean energy, and their manufacturing, then mechanical engineering is the best choice to prove your ability and interest, and you can find your career which you wish to in this branch. UPS has also been inclined towards the research component, or to increase the enthusiasm between the students regarding the research content. So every year we just organize RISE, Research Initiative for Students of Engineering, in which we just ask for the proposals from the students and encourage them to generate a certain prototype, or to convert, in which they have been given funding institution to convert their ideas to reality, to a form of prototype, to a form of certain process, and they've been awarded every year. So this is a process, or this is an initiative which we have been working on since years and years, to encourage students into the research area, or to increase the practical knowledge of the students apart from the theory one. So come and join UPS if you want to grace your career with industry-oriented teaching, research environment, and of course, with our well-equipped facilities, with all our specialized facilities that we have. So I would like to welcome you at UPES Dehradun. If any questions are there, most welcome. If there are any questions, I would like to answer them. The job opportunities are endless in mechanical engineering. If you pursue your career, or you have done your undergraduate or graduation in mechanical engineering, you can find your job. Placements are one of the things. Of course, you can get your job through placements, but there are other a lot of prospectus or a lot of opportunities are there which can which you can offer. You can go to an defense sector, you can opt for PSUs, you can go to any industry, any private, public sector, government sector industry which is involving of production, design, management, anything. Then you can also, if you want to pursue your government sector jobs, then you can go for GATE. You can give your GATE exams. If you want to pursue your higher education, you can opt for MTechs and all. But job opportunities, like, you can find it anywhere where production is being there, where services are there. Like, let's take an example in my slide, ITC hotels are there. So this is a service sector industry. You have your jobs there. They have visited us, and they are being in a process of hiring our mechanical students. We have with Tata Technologies, we have with us. So career prospectors or the career opportunities are endless in mechanical engineering. You can go for government sector, you can go for private sector, different industries are there. You can go to automotive sectors, you can go to Hyundai, you can go to Maruti, you can go to any automotive sector, Man Trucks India. You can go to public sectors like BHEL, you can opt for HPCL, BHEL, and so on. So thank you all for there with me, and you have been most welcomed to our university, University of Petroleum and Energy Studies. Thank you so much.